Today you will learn what features are when talking about SOLIDWORKS CAM and CAMWorks. I will show you different feature types, how to identify them, and why the CAM software is working on features in the first place. Hi, this is Tim from CADWorks.dk. If you are looking for videos about SOLIDWORKS, SOLIDWORKS CAM and CAMWorks, you have found the right channel. I will make guides, tips and tricks, as well as demo videos that might educate, inspire, or just interest you. If this is your first time watching, be sure to subscribe to the channel and never miss out on any content again. I would also recommend reading the description text below, as there might be useful stuff related to this video. In case you have any ideas for upcoming content or comments to this video, please leave a comment in the comments section. Enough with the intro, let's get started. In the last video I went through the initial setup in CAM. I realized I forgot an important step, how to enable the CAM add-in in the first place. So let's start there. After that I'll talk about features and what they are when it comes to CAM software. There are a bunch of different 2.5 axis feature types, and after this I'm pretty confident you will know how to recognize them. CAMWorks was the first CAM system to automatically detect features in SOLIDWORKS, and a fun fact is, if you have ever used FeatureWorks in SOLIDWORKS to find features on a step file, for instance, that is CAMWorks technology right there. I'll swap over to the application view and start by showing how to start. Add in CAM, define setup as a recap, and then talk about the feature types. And hang on to the end where I'll show different settings to speed up programming toolpath. Okay, first things first. Let's start by adding in SOLIDWORKS CAM, and this can be done from the tools and add-ins or from the drop-down and add-ins dialog. This is a SOLIDWORKS add-in, so you'll find that right here, and that is called SOLIDWORKS CAM 2020 currently. For the active session you can set a tick mark in the left column, and if you want to start up SOLIDWORKS CAM always, you can set a tick mark in the right column. And obviously if you have CAMWorks, you do not want to set SOLIDWORKS CAM to start up or active at any point, you want to run the CAMWorks add-in instead. But for these simple videos, the SOLIDWORKS CAM is going to be just fine. So clicking OK in the add-ins dialog is going to add in two new tabs, SOLIDWORKS CAM and SOLIDWORKS CAM Tolerance-Based Machining. The Tolerance-Based Machining we will look into in a later video. We also get the three icons for the machining, that is SOLIDWORKS CAM Feature Tree, SOLIDWORKS CAM Operation Tree and SOLIDWORKS CAM Tools Tree. Let me start by going to the SOLIDWORKS CAM Feature Tree. And as a recap, I'm going to double click on the machine. I'm going to select the machine, the tool grip. And as a good practice, I want to remove this use tool grip tools only, at least until I have all the tools in my tool list that I have on the machine as well. So I recommend not having this use tool grip tools only. For post processor, let's go with the hash. And OK. Next up is to define the coordinate system. And for this part, I probably want to have it in the center. So for part bounding box that sits on top, that is just fine. And then the stock manager, I want to use a bounding box based from the fixture coordinate system. And I want to add some material, so 3 mm in both X directions, 3 mm in both Y directions, and maybe 2 mm on the Z levels. So now I have a block where my part sits inside. So let's talk about creating features that we can machine. This one I want to face off, and then I want to run a tool on the perimeter of the part. So first off is to create a Millepied Setup. So right click on coordinate system or on stock manager and select the Millepied Setup. Then select a face that is perpendicular to the machining direction. So this faces just fine. I don't want to have anything selected in this Millepied setup, so hitting OK. To create features that we can machine, an easy way is to right-click on the Midpart Setup and select 2.5 axis feature. In this dialog, you have some different types to select from. We have a face feature, we have pocket, slot, corner slot, and so on. But I want to start up with a face feature, obviously. There is a group called Selection Filter, and I will cover those a bit later on in another video. Then we have selection method. So you can select from available sketches, or you can select directly off the model. And I recommend using the model as much as you can. So with this one, you can select the face, and you'll see that there is a valid profile, and you can go to the end condition page. From here, you can select the type of strategy that you want to apply. So we are using data from a technology database, which you can teach. So you have your best practices for machining strategies available. And we are not going to cover that. We are just going to go with the defaults for this session. For the end condition, you can say up to stock, or you can select different other types like you can for extrudes in SOLIDWORKS. But for this one, this is just fine. You can see that we draw a box shape on top of this one, and this corresponds to the material that we are going to remove off this part. You have an additional direction if you need that. For feature profile, we are set to use stock extents. What that means is we are going to expand the selection to the stock. If I remove this one, only the circular face is highlighted. This is not what we want, obviously. We want to machine off the entire part stock. There is also option for defining islands. That would be if there is a boss, for instance, on this surface. But in those cases, I would probably rather use an open pocket feature. So skipping that one for now. So that inserted a face feature. Now let's go and create a perimeter feature, machining away following this contour. And for this, we actually have a special selection called a part perimeter feature. With this, it's going to detect the perimeter of the part file as well as the boundary of our setup. And we have two different types we can utilize. We can either use a boss, which is essentially going to run a contour mill, or an open pocket, which is going to run a rough mill and then a contour. Difference between the two is if I run the contour only, it is going to be cutting close to the surface, whereas the open pocket is going to remove all of the material and then run a finish pass. So for this example, I think open pocket is a very good approach. For the depth, I would like to go 0.5 millimeters below the part, and you can see that it drops down, and hit OK. So now we have created two different features. We have a face feature and we have a contour or perimeter feature. Let me create operations for these. So clicking on the setup, create machining operation, click on the setup again and create toolpath. So now we have a face mill, we have a rough mill, and we have a contour mill. And basically that is all we need for this part. For this example, I'm going to create the Midpart setup again. So I'm going to double click the machine, select the correct machine, the right tool grip, make sure we are not using tool grip tools only, and then post processor. Everything is okay. Define the coordinate system, and I want to have it on the part bounding box at this corner. And this is actually sitting correct, so that is just nice. And then add some additional stock to this one. For this one I only want to have material on top in relation to the fixture coordinate system, so adding 2 millimeters. And again, I'm going to create a Millepied setup coming in from this direction. I want to create a face operation first, so new 2.5 axis feature, face feature on that face. Going up to stock using stock extend. And then I want to program this surface. And that is an open pocket. I could have been using a face feature for this, but an open pocket is much better for these ones. Right click on Millepied Setup, 2.5 axis feature, and then select the open pocket. For the open pocket surface, I'm going to select this one. As my end condition, I want to machine up to this surface. And now I am going to go to the next page, or the last page, which is the island page. And from in here I can select the same boss again, and that would avoid to mill away this one. Or I could decide to run auto detect and let CAMWorks or SOLIDWORKS CAM pick up the geometry. And everything is okay, so hitting OK. I also have a pocket inside, so let's program that as well. So right click on the Midpart Setup, 2.5 axis feature. Under type, I want to select a pocket. Then I select the bottom, go to end condition, and select the top. For this one, the strategy is suggested as rough, rest, and finish. And maybe that is a good idea, so let's just keep it that way. And now we have face, open pocket, and irregular pocket. So let's generate operation plan for these ones. And some toolpath. And let's see what we have. So we have a face mill. We have a rough mill, avoiding the boss on the face. We have a contour mill. We have a rough mill coming on the inside pocket. Then we have another rough mill cleaning up where the larger tool did not fit in. And then a contour mill cleaning up the walls. So let me flip this one over and focus on this pocket. So in this pocket we also have a boss, so we have a pocket with an island. And this is, by the way, on the opposite side of the initial setup. So I will go into the CAM feature tree, right click on the stock manager and make a new Midpart setup. Select the machining direction, deselect the face and hit OK. Programming this pocket is very easy, so I just right click on the Midpart setup, make a new 2.5 axis feature, select the pocket type and select the bottom. For the end condition, I will select the top. As strategy for this one, I want to run rough and finish only. Then on the final page, I will auto detect if there are any islands, and SOLIDWORKS CAM will pick up on the boss feature inside. So hitting OK, generating operation plan and creating toolpath is going to machine this one just fine. So now we can run a toolpath simulation. First on this one. So I will go to the next setup and just play through this one. and everything's looking fine. Flip this one over and have a look at the other setup. And now we can compare by show difference and see that everything is in green, which means our target part has been machined. And I can see in this one there are some areas in blue, and that means I have not machined to the inside of the tolerance of the part. That is, however, very easy to fix. So let me just have a look at this one. It's a radius 3 and my contour is using a 10. So obviously that is not working. So let me just find this contour mill and put that at a different tool. Basically I don't have a tool. Anyway, I will right click and add a tool from library. So that is a flat end. Let's go for 6mm. And then I can take my contour and drag that onto that 6mm, and that would update the toolpath instantly. Perfect. Let's look at another part. So here we have different slot types, and if I again go into the feature tree, double click the machine, make sure that my machine is selected, the tool grip is selected, and I allow to use tools that are not only in the tool grip, and then select the post processor. Everything's fine. Go to the coordinate system and select the part bounding box, and I want to have it on this corner. And this time the axes are pointing incorrectly. I want the Z axis to point upwards, so to correct that I just select the selection box and select the surface, and that is going to orient the Z axis correctly. Now the X axis is pointing incorrect, so I will select that field, click on that surface, and everything is then oriented the way I want it. For the stock, basically I don't want to do anything, so just verifying that everything is set to 0. Actually let's add fixture coordinate system and add 1mm to this one. And now right click Midpart Setup, select the surface that you want to machine, remove this one and hit OK. So now I want to face this one before I start working on these different slots. So right click, 2.5 axis feature, a face feature, select any of these faces and go to end condition. This will go up to stock using stock extend and OK. And now let's program these different slot types. So right clicking again and selecting the 2.5 axis feature, you will notice that we have different types of slots. We have slot and corner slot. And basically slots are the same as open pocket, with a twist, I would say. So it really doesn't matter if you select slot or corner slot. The definition of the slot is that it enters one surface and exits another surface which is not connected. So this would be a slot, this would be a slot, and this would be a slot. A corner slot will have 2 or more edges connected, so this would be a corner slot or this would be a corner slot. But essentially these are only kept for legacy purposes, so whichever you select is going to be fine. So I'll just go for the slot option. Now I want to start by programming this one. and then go to the end condition and select the surface. So this gives us the area that we are going to machine. And you can see, hopefully, that lines in here are solid lines, whereas these ones are dashed and open lines, meaning that this is open segment. The tool can enter and exit freely. There is no collision. And when it's a solid line, then it knows that there's material behind it. As a strategy, I want to go rough and finish. And hit OK. I can continue and add a new 2.5 axis feature. Add another slot. Selecting this one. As end condition, I want to go up to this surface. And again, you can see the open lines and the solid lines. And hit OK. And we can do that one more time. Selecting this surface. End condition is this surface, and we have the open lines indicating that tool is free to enter and exit. Rough and finish. And OK. And now I can generate the operation plan as well as toolpath. And we can simulate the result. And compare the differences. So we can see that everything is machined except these two areas where we need to program a little bit more. So let's program the last two. Going back to the feature tree, right click on Midpart Setup, insert 2.5 axis feature, and select this and this slot, because you can select multiple in one operation. End condition and up to face. Rough and finish. And OK. This is going to create two individual features that you can use later on. But for now, I will select one, control select the other one, and create the operation plan for these two. Select the rough mill 5, use shift and select the last one and create toolpath. And then we can simulate again. And obviously we are going to have something in blue because we cannot machine this tight corner anyway. But that should be just fine. So let's open up the next part file. Again, I'm going to go into the SOLIDWORKS CAM feature tree. I'll double click the machine. Make sure that my machine is selected, that the tool grip is selected, and I'm using tools outside the tool grip, and that the post processor is the correct one. Then I want to look at the coordinate system. I want to place that in this corner, and again I need to adjust the Z axis. Everything's looking good, so OK. Then I'm going to right click and create a Millepied Setup. I want to come in from this direction and hit OK. And this time I'm going to use the feature recognition because that is just perfect for detecting holes. And to do so, I'm going to right click on SOLIDWORKS CAM and select Options. And in the mill features, I will deselect everything except for the holes and hit OK. I could easily right click, create a 2.5 axis feature and select hole and then point to different holes. But that is just too much work, and I really don't want to do that. So in these cases, I will run extract machinable features. So I will right click on my Millepied Setup and recognize features. This is going to look at the part file, and it will create, in this case, a whole group with 8mm tap, a drill, another drill, and a counterbar. So let's see what comes out of this one. I will generate the operation plan and generate toolpath. So we got a center drill, a drill, and a tap. We get a center drill and a drill. We get a center drill and a drill. We get a center drill and a drill. And then we get a contour and a contour and a contour. If I simulate this, we actually go in and chamfer this edge, and we rough and finish cut the counterbore. But what if these holes were ream holes? So let me go back and find this one. Imagine that these holes were supposed to be done with a ream tool. I would then double click, and as a strategy, I would select ream. Hit OK. Right click and then generate operation plan. And because operation plan already exists, we want to regenerate it. This is going to bring in a center drill, a drill, and a ream. The same is true for these tapped holes. If this one was not detected as a thread, we could actually use this one as an example. I could right click and select parameters. We can see that the diameter is 12.5, so I could select a thread. And then from the thread library, we could select something with a diameter of, so that would be a 14mm thread with a pitch of 1.5. And I could then generate the operation plan again, regenerate, and that would bring in center drill, drill, and a tap. Let's look at another part. In this case, I want to machine only this contour. So I will again go into the feature tree, double click the machine, make sure that my machine is selected, my tool grip is selected, and I allow using other tools, and that the post processor is correct one. Set the coordinate system, which is correct, and define our stock. Then I right click, make a Midpart Setup on this surface. And in this case, I only want to machine the front contour. So I will right click, make 2.5 axis feature. This is an open profile, or it could be a curve feature, but open profile. Then I select this line, Control select this line, and we will chain everything in between. As end condition, I will go to this surface and hit OK. Generate the operation plan and the toolpath. Let's have a look at this part again. Here we have an engravement, so I want to do that, and I will do that from the feature tree. I need to create a new setup, so I will right click, Millepied Setup, and on this surface. This time I'm going to right click and select 2.5 axis feature and then select the engrave feature type. I know that sketch 4 contain the letters that you see, and those are the ones that I'm going to engrave on. As end condition, I'm not going to go 10 millimeters deep, maybe 0.5. And hit OK. Generate the operation plan and the toolpath. And we can see that we programmed that one as well. The final one that I'm going to show is the multi-surface strategy. So again, I'm going to feature tree, double click the machine, make sure that correct machine, tool grip and priority is set, and that I'm using the right post processor. Then I'm going to define the coordinate system. For the x-axis, I will select the bottom and flip that. And for the stock, it actually looks quite good. And now I'm going to program this part. So right click, Midpart Setup, and again select the bottom. And the reason I'm selecting the bottom is everything looks kind of curved on top, but I know that the bottom is flat, so I can just select that one and then flip the direction. Right click, and this time using a multi-surface feature. I will not cover this in great detail, but I'm going to select all displayed, and for strategy it's area clearance and set level, and hit OK. Then I'm going to click on that one and create the operation plan, create the toolpath, and this time it's a semi 3D operation, so it's going to take a little bit longer. But now the toolpath are generated, and I can go in and simulate. It might not be a good idea to start inside, so I'll just stop the simulation and go to my area clearance. Plug it in, and maybe let's go past and preview that. And again, all of these conditions I'm going to cover in greater details later on, but this one is looking just fine. So now I can simulate the toolpath. And of course we can always play with the tolerances so we can get a much finer surface. That's all for this video. I hope you found some useful information in this one and got a bit more educated on the software. In the next video I'll show the basic concepts on creating toolpath and how to optimize the CAM program. I want to thank you for your time and remind you to subscribe to the channel. Feel free to ask questions or suggest any other relevant topics. All comments are being read and I'll do my very best to always answer your questions.